Hi guys, today we're going to take a look at question 1 from paper 2 of the 2015 exam. Okay, so we start off with, we have an experiment consisting of throwing two fair standard six-sided die, and of course we, as always, note what's relevant, and noting the sum of the two numbers thrown. Okay, sum of the two numbers thrown. If the sum is 9 or greater, okay, 9 or greater, it is recorded as a win. Okay, so if they roll a 9 or greater, it's a win. And if the sum is 8 or less, it is a loss. Okay, sum is 8 or less, it is recorded as a loss. Alright, so let's just, before we take a look at the question, let's just take a look at this game. Okay, so let's call the result from dice 1, let's call that D1. So that can take numbers from 1 to 6, and it takes those numbers with equal probability because it's a standard fair die. Alright, and let's say the result from dice 2 is D2. Okay, and now we've got a formula for what is a win. Okay, so we get a win, W, if the sum of the two die, so D1 plus D2, is 9 or greater. Okay, so greater than or equal to 9. And a loss if the sum is less than or equal to 8. Alright, so now we've got a formula for the win. Okay, so now we want to fill in this table. Complete the table below to show all possible outcomes of the experiment. Okay, so this is a very, very simple start. So here we have a loss. So 1 plus 1 is 2, less than 8. Loss. 1 plus 2. So, I mean, it can only be 6. So if one of them is 1, it's always going to be a loss. So we can just immediately fill in losses here and here. And if it's a 2, if one is a 2, the other one can only be a 6, so we can only reach 8. So we can immediately count these as losses. And now, this is where it gets a little bit more work. Okay, so 3 and a 3 is a 6, so this is a loss. 3 and a 4 is a 7. Oops, that's not what we're supposed to do. 3 and a 5 is an 8. 3 and a 6 is a 9. Oh my god, I keep doing that. Loss. And a W. And now 4 plus 3 is a 7, so that's a loss. 4 plus 4 is an 8. Loss. 4 plus 5, 9. Win. 4 plus 6, 10. Win. 5 plus 3, loss. 5 plus 4, 9. Win. 5 plus 5, 10. Win. 5 plus 6, 11. Win. And now 6 plus 3, win. 6 plus 4, win. 6 plus 6, 12, win. And very, very nice start. Now on to part B. Find the probability of a win on one throw of the two dice. Alright, so a win on your first try. Find the probability of a win on one throw of the two dice. Okay, so the trick here is to realize that all these outcomes in these boxes in the table, all of the outcomes are equally likely because there's only one way it can happen. So the chance of die 1 being a 4 and die 2 being a 2 is the same as die 1 being a 6 and die 2 being a 6. All these things are equally likely. And so because of that, we can just add up, we can just count the number of losses and then divide it by the number of outcomes. So all events equally likely, and so if it's kind of a trick with probability, if all events are equally likely, then you can just probability of a win is just number of wins of ways to win over the number of possible outcomes. Okay, so let's count the number of ways to win. Well, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we have 10 ways to win. So 10 ways to win. And there are 6 times 6 possible outcomes. 36. So the probability is just 5 over 18. Now for part 2 of B, find the probability that each of 3 successive throws of the 2 dice is a loss. Give your answer correct to 4 decimal places. Alright, so the trick here is that the events, so the throws of the dice are independent. Okay, so what does that mean? Well, if things are independent in probability, then independent means two events are independent if one happening does not alter the likelihood of the other happening. So for example, if you throw a coin and it lands on heads, and you throw a second coin, the chance that it lands on heads, if it's a fair coin, is still 50-50. It doesn't matter what the results of the first coin was, because when you throw coin, your results are independent of the second happening. And it's the same with throwing a dice, or in this case, throwing 2 dice and adding the scores. And so when things are independent, the probability of the first thing happening, let's call it A, probability of A, and the second thing happening, and B, is just the probability of A times the probability of B. And let's just call that prob B, so I don't run out of space. So for example, if I flip a coin and it lands on heads, and I flip a coin and it lands on heads again, the chance of that happening were 1 over 2 times 1 over 2, 1 over 4. Okay, so we're going to use that to solve this question. Find the probability that each of 3 successive throws of the 2 dice result in a loss. Alright, well, one has to result in a loss, and then another, and then another. And those 3 things are independent. So let's call the first happening in a loss, let's call that A. The second resulting in a loss is B, and the third resulting in a loss is C. And the probability of each of them is just well, you either win or you lose, and you win with 5 over 18, so you lose with 13 over 18, because it has to sum to 1. So A, B, and C, they each have probability 13 over 18. And they all have to happen for you to lose 3 in a row. So the probability, let's just call that P, of A and B and C is just probability of A times the probability of B times the probability of C. And so it's just 13 over 18 by 13 over 18 by 13 over 18, or just 13 over 18 cubed, which is 13 over 18 cubed is 0.3767. Well, 3767146, but to 4 decimal places, so 0.3767. Now on to the last part. The experiment is repeated until a total, okay, so it's repeated until a total of 3 wins occur. Find the probability that the third win occurs on the 10th throw of the 2 dice. Probability third win occurs on the 10th throw of the 2 dice. Give your answer correct to 4 decimal places. Okay. Well, we've got to think, how would this happen? Okay. Well, if the third win, what is the question telling us? Third win is on the 10th time. On the 10th go. Which means in the first 9 goes, there were exactly 2 wins. So there are 2 wins in the first 9 goes. 9 goes. So that means there's 7 losses in the first 9 goes. Well, what's the probability that that would happen? Well, we've got 2 wins, and remember these are independent, and the probability of a win is 5 over 18. So these 2 happen, so we've got 5 over 18 squared. And then we've also got 7 losses. So we have 13 over 18. Not squared, sorry, to the power of 7. Okay, but we've got to think, how many different ways can this happen? Well, the number of ways that this can happen, so let's say we're going to choose which of the 2 were wins. Well, there's 9 of them, and we're choosing 2, and we actually have a formula for that. We know that that's 9 choose 2 on your calculator. So that's the number of ways it can happen. So that whole thing is 5 over 18 squared by 13 over 18 to the 7 by 9 choose 2. And that is 0.2847. 0.2847. So the probability that we get to the 10th go with 2 wins, 2 wins out of 9, is 0.2847. So, and then we have to win the next one. So we have to get 2 wins out of 9, and then we have to win. And these things are independent. So we're looking for the probability 2 wins out of 9 and a win on the next go, and win. And since these are independent, we can just go probability 2 wins out of 9 by the probability of a win. So we can just, we have the first one, 0.2847, and we have the second one. We already calculated the probability of a win. So that's by 5/18. So this is just by 5/18, 0.07908, which is just 0.791 because we're rounding to 4 decimal places. And so that's just, it's just as simple as that. This is a little bit trickier, but you've just got to think, how would this happen? And what's the probability of that happening?